everyone. Today we are going to be continuing our geometry unit, and you guys are going to be watching some videos on geometric transformations. Make sure you have a piece of paper out, something to write with. Make sure you're ready to pay attention because you will be taking a quiz throughout this video as you watch each of the different videos. Okay, so just like we did with the last lesson. This is going to be the only other lesson for this week. So if you get finished with this lesson, you do not have math again until Monday. So I hope you have an awesome weekend. If you are having any questions as you go through these videos and you're not understanding very well, please text me 801-644-9940 or email me. I am in the classroom with you, so just raise your hand and I can move you to a breakout room and we can work together, okay? Whatever you need, I'm here for you. So with that said, let's go ahead and start our first video.
What I hope to introduce you to in this video is the notion of a transformation in mathematics. And you're probably used to the word in everyday language. Transformation means something is changing. It's transforming from one thing to another. So what would transformation mean in a mathematical context? Well, it could mean that you're taking something mathematical and you're changing it into something else mathematical. That's exactly what it is. It's talking about taking a set of coordinates or a set of points and then changing them into a different set of coordinates or a different set of points. For example, this right over here, this is a quadrilateral. We've plotted it on the coordinate plane. This is a set of points, not just the 4 points that represent the vertices of the quadrilateral, but all the points along the sides too. There's a bunch of points along this. You could argue there's an infinite, or there are an infinite number of points along this quadrilateral. This right over here, the point x equals 0, y equals -4. This is a point on the quadrilateral. Now, we can apply a transformation to this. And the first one I'm going to show you is a translation, which just means moving all the points in the same direction and the same amount in that same direction. And I'm using the Khan Academy translation widget to do it. So let's translate. Let's translate this, and I can do it by grabbing onto one of the vertices. And notice I've now shifted it to the right by 2. Every point here, not just the orange points, has shifted to the right by 2. This one has shifted to the right by 2. This point right over here has shifted to the right by 2. Every point has shifted in the same direction by the same amount. That's what a translation is. Now I've shifted. Let's see, if I put it here, every point has shifted to the right one and up one. They've all shifted by the same amount in the same direction. That is a translation, but you can imagine a translation is not the only kind of transformation. In fact, there's an unlimited variation. There's an unlimited number of different transformations. So, for example, I could do a rotation. So I have another set of points here that's represented by quadrilateral, I guess we could call it CD or BCDE, and I could rotate it. And I would rotate it around the point. So for example, I could rotate it around the point D. So this is what I start with. Let me see if I can do this. I could rotate it like, actually let me see. So if I start like this, I could rotate it 90 degrees. I could rotate 90 degrees. So I could rotate it like, that looks pretty close to a 90-degree rotation. So every point that was on the original, or in the original set of points, I've now shifted it relative to that point that I'm rotating around. I've now rotated it 90 degrees. So this point has now mapped to this point over here. This point has now mapped to this point over here. And I'm just picking the vertices because those are a little bit easier to think about. This point has mapped to this point. The point of rotation, actually, since D is actually the point of rotation, that one actually has not shifted. And just so you get some terminology, the set of points after you apply the transformation, this is called the image of the transformation. So I had quadrilateral BCDE. I applied a 90-degree counterclockwise rotation around the point D. And so this new set of points, this is the image of our original quadrilateral after the transformation. And I don't have to just, let me undo this, I don't have to rotate around just one of the points that are on the original set, that are on our quadrilateral. I could rotate around the origin. I could do something like that. Notice it's a different rotation now. It's a different rotation. I could rotate around any point. Now let's look at another transformation, and that would be the notion of a reflection. And you know what reflection means in everyday life. You kind of imagine the reflection of an image in a mirror or in the water. And that's exactly what we're going to do over here. So if we reflect across a line. So let me do that. So this, what is this? 1, 2, 3, 4, 5. This not irregular pentagon. Let's reflect it. And to reflect it, let me make a line like this. I can reflect it across a whole series of lines. Whoops, let me see if I can. So let's reflect it across this. Now what does it mean to reflect across something? One way I imagine is if this was, we're going to get its mirror image, and you kind of imagine this as kind of the line of symmetry, that the image and the original set of the original shape, they should be mirror images across this line. And we could see that. Let's do the reflection. There you go. And you see we have a mirror image. This is this far away from the line. This corresponding point in the image is on the other side of the line, but the same distance. This point over here is this distance from the line, and this point over here is the same distance, but on the other side. Now, all of the transformations that I've just showed you, the translation, the reflection, the rotation, these are called rigid transformations. And once again, you could just think about, what does rigid mean in everyday life? It means something that's not flexible. It means something that you can't kind of stretch or scale up or scale down. It kind of maintains its shape. And that's what rigid transformations are fundamentally about. If you want to think a little bit more mathematically, a rigid transformation is one in which lengths and angles are preserved. You can see in this transformation right over here, the distance between this point and this point, between points T and R, and the distance between their corresponding image points, that distance is the same. The angle here, angle RTY, the measure of this angle over here, if you look at the corresponding angle in the image, it's going to be the same angle. So you might, and the same thing is true if you're doing a translation. You can imagine these are kind of acting like rigid objects. You can't stretch them, and they're not flexible. They're maintaining their shape. Now, what would be examples of transformations that are not rigid transformations? Well, you can imagine scaling things up and down. If I were to scale this out where it has, maybe the angles are preserved, but the lengths aren't preserved, that would not be a rigid transformation. If I were to just stretch one side of it, or if I were to just pull this point while the other points stayed where they are, I'd be kind of distorting it or stretching it. That would not be a rigid transformation. So hopefully this gets you, it's actually very, very interesting. I mean, when you use an art program, or actually use a lot of computer graphics, or you play a video game, that most of what the video game is doing is actually doing transformations, sometimes in 2 dimensions, sometimes in 3 dimensions. And once you get into more advanced math, especially things like linear algebra, as a whole field, it's really focused around transformations. In fact, some of the computers with really good graphics processors, a graphics processor is just a piece of hardware that is really good at performing mathematical transformations so that you can immerse yourself in a 3D reality or whatever else. So this is really, really interesting stuff.
So in that video, Saul talked about 3 different transformations that I need you to know, okay? So on your piece of paper, write down question number 1, and I want you to write translation, rotation, and reflection, okay? And then I want you to write yourself a little bit of a description about what each of those transformations is, okay? And we're going to watch another video right now where we're going to practice identifying some transformations, and then we will have your quiz questions 2 and 3.
What we're going to do in this video is get some practice identifying some transformations. And the transformations we're going to look at are things like rotations, where you are spinning something around a point. We're going to look at translations, where you're shifting all the points of a figure. We're going to look at reflection, where you flip a figure over some type of a line. And we'll look at dilations, where you're essentially going to either shrink or expand some type of a figure. So with that out of the way, let's think about this question. What single transformation was applied to triangle A to get triangle B? So it looks like triangle A and triangle B, they're the same size. And what's really happened is that every one of these points has been shifted, or another way I could say it, they have all been translated a little bit to the right and up. And so right like this, they have all been translated. So this right over here is clearly a translation. Let's do another example. What single transformation was applied to triangle A to get to triangle B? So if I look at these diagrams, this point seems to correspond with that one. This one corresponds with that one. So it doesn't look like straight translation because they would have been translated in different ways. So it's definitely not a straight translation. Let's think about it. It looks like there might be a rotation here. So maybe it looks like that point went over there, that point went over there, this point went over here. And so we could be rotating around some point right about here. And if you rotate around that point, you could get to a situation that looks like triangle B. And I don't know the exact point that we're rotating around, but this looks pretty clear, like a rotation. Let's do another example. What single transformation was applied to quadrilateral A to get to quadrilateral B? So let's see, it looks like this point corresponds to that point. And then this point corresponds to that point, and that point corresponds to that point. So they actually look like reflections of each other. If you were to imagine some type of a mirror right over here, they're actually mirror images. This got flipped over the line, that got flipped over the line, and that got flipped over the line. So it's pretty clear that this right over here is a reflection. All right, let's do one more of these. What single transformation was applied to quadrilateral A to get to quadrilateral B? All right, so this looks like, so quadrilateral B is clearly bigger. So this is a non-rigid transformation. The distance between corresponding points looks like it has increased. Now you might be saying, well, wouldn't that be, it looks like if you're making something bigger or smaller, that looks like a dilation. But it looks like this has been moved as well. Has it been translated? And the key here to realize is around what is your center of dilation. So for example, if your center of dilation is, let's say right over here, then all of these things are going to be stretched that way. And so this point might go to there, that point might go over there, this point might go over here, and then that point might go over here. So this is definitely a dilation where your center where everything is expanding from is just outside of our trapezoid A.
Now we are ready to practice some of these transformations on our own. So follow along as we go through these questions. Okay, so this is question number 2 on your piece of paper. What single transformation was applied to triangle A to get to triangle B? So is this a translation, a rotation, or a reflection? Or is it a dilation? So for this one, you can see that this one would be a rotation. So this is question number 3 on your piece of paper. What single transformation was applied to triangle A to get to triangle B? Was it a translation, a rotation, a reflection, or a dilation? Okay, so for this one, we can see that triangle A and triangle B are exactly the same size, so we know it's not a dilation. We also know it's not a reflection. It's not the mirror image. They're facing the same direction. We know it's not a rotation. This would actually be a translation. It looks like if we move each of these points to the right, 1, 2, 3, and down, 1, 2, 3, 4, that will map one triangle onto the other triangle. So we would call this a translation. Okay, is number 4 on your piece of paper, and we want to answer the question, what single transformation was applied to quadrilateral A to get to quadrilateral B? So we know it's not a translation, and we know it's not a reflection, we know it's not a dilation, this would be a rotation. In this next lesson, we are going to learn how to translate a point.
What we're going to do in this video is look at all of the ways of describing how to translate a point, and then to actually translate that point on our coordinate plane. So for example, they say plot the image of point P under a translation by 5 units to the left and 3 units up. So let's just do that at first, and then we're going to think about other ways of describing this. So we want to go 5 units to the left. So we start right over here. We're going to go 1, 2, 3, 4, 5 units to the left. And then we're going to go 3 units up. So that's going to be 1, 2, 3. And so the image of point P, I guess, would show up right over here after this translation described this way. Now, there are other ways that you could describe this translation. Here we described it just in plain English by 5 units to the left and 3 units up. But you could, and this will look fancy, but as we'll see, it's hopefully a pretty intuitive way to describe a translation. You could say, look, I'm going to take some point with the coordinates x, comma, y. And the x-coordinate tells me what's my coordinate in the horizontal direction, to the left or the right. And so I want that to be 5 less. So I would say x minus 5, comma, y. And what do we do to the y-coordinate? Well, we're going to increase it by 3. We're going to translate 3 units up. So y plus 3. So all this is saying is whatever x and y coordinates you have, this translation will make you take 5 from the x. That's what, meaning this right over here is 5 units to the left. And then this right over here is saying 3 units up. Increase your y-coordinate by 3, decrease your x-coordinate by 5. And so let's just test this out with this particular coordinate, with this particular point. So in this point right over, P has the coordinates, its x-coordinate is 3, and its y-coordinate is -4. So let's see how that works. If I have 3, comma, -4, and I want to apply this translation, what happens? Well, let me just do my coordinates. And so I started off with 3 and -4, and I'm going to subtract 5 from the 3. So subtract 5 here. We see that right over there. And we're going to add 3 to the y. So notice, instead of an x, now I have a 3. Instead of an x, now I have a 3. Instead of a y, now I have a -4. Instead of a y, now I have a -4. And so another way of writing this, we're going from 3, comma, -4 to 3 minus 5 is -2, and -4 plus 3 is -1. So what are the coordinates right over here? Well, the coordinate of this point is indeed -2, comma, -1. So notice how this, you could say this formula, the algebraic formula that shows how we map our coordinates, how it's able to draw the connection between the coordinates. And so you'll see questions where they'll tell you, hey, plot the image, and they'll describe it like this. Translate x units to the left or the right, or 3 units up or down. You'll sometimes see it like this, but just recognize this is just saying take your x and subtract 5 from it, which means move 5 to the left. And this just means take your y-coordinate and add 3 to it, which means move 3 up. And sometimes they'll ask you, hey, what's the new coordinate? Or sometimes they'll ask you to plot something like that. But just realize that it's all the same underlying idea.
So this is question number 5 on your piece of paper. It says point Q is the image of point Q, whatever, apostrophe, I'm not sure what that is. But it's going to be the translation of the point, basically. So the translation of point Q is the image of Q, 0, 6, under the translation to the right 7 and down 5. So if we take the x and we let that be 0, 0 plus 7 is 7. And if we take the y and we let that be 6, 6 minus 5 is 1. Okay, so for the next question, this is question number 6 on your piece of paper. It says, the translation of point Q is the image of Q at negative 5, 1 under a translation by 6 units to the right and 2 units down. So if we take negative 5 and we move 6 units to the right, that means we're going to add 6. So negative 5 plus 6 would be a 1. And if we take the 1 and we move 2 units down, that's going to be 1 minus 2, which is a negative 1. For the last one, this is question number 7 on your piece of paper. We are supposed to plot the image P under a translation by 5 units to the right and 7 units down. So if I move 5 units to the right, 1, 2, so 1, 2, 3, 4, 4, 5 units to the right, and then 7 down, 1, 2, 3, 4, 5, 6, 7 units down. Oh, that's not letting us do this correctly. So it'd be this point right here. Okay, the point 4, negative 2. That would be a translation of 5 to the right and 7 down. So far in class, we have learned about 4 different types of transformations: translation, rotation, reflection, and dilation. Okay, and hopefully by now you can identify what kind of transformation is happening. And then we spent some time talking about how to translate a point, and we're going to continue learning how to translate a shape, and then we'll continue with the rest of this lesson on Monday. We will talk about rotation, reflection, and dilation. So let's finish up with learning about translations. The next part of our lesson is on
triangle ABC undergoes the translation, and we show we're using the notation capital T for it, and then we see what the translation has to be. We're going to move, it's kind of small, I hope you can see it on your video screen. We're going to move positive 8. Every point here is going to move positive 8 in the x direction. Its x coordinate is going to increase by 8, or the corresponding point in the image is x coordinate is going to increase by 8, and the corresponding point in the image's y coordinate is going to decrease by 1. So let's do that. And I'll focus on the vertices. Whoops, let me drag that to the trash. I didn't mean to do that. I'm going to focus on the vertices because that's the easiest thing for my brain to work with. So, and actually this is what the tool expects as well. So the point B is going to move 8 to the right, or its corresponding point in the image is going to have an x-coordinate 8 larger. So right now the x-coordinate is negative 4. If you added 8 to that, it would be positive 4. And its y-coordinate is going to be 1 lower. Right now, point B's y-coordinate is 8. 1 lower than that is 7. So in the image, the corresponding point in the image would be right over there. And you see we moved 8 to the right and 1 down. Let's do that with point C. It's at x equals negative 7. If you move 8 to the right, if you increase your x-coordinate by 8, you're going to move to x equals 1. And then if you change your y-coordinate by negative 1, you're going to move down 1. Then you're going to get to that point right over there. Now let's do it with point A. So point A's x-coordinate is negative 1. If you add 8 to it, it's going to be positive 7. And its current y-coordinate is 2. If you take 1 away from it, you're going to get to a y-coordinate of 1. And so there you have it. Let's see, how do I connect these two? Oh, there you go. And we can check our answer, and we got it right. We have performed the translation. we're asked to use the translation tool to determine the translation that will map triangle WIN, so this right over here, onto the other triangle. So let's see if we can translate this thing. So I'm going to use the translation tool. So I'm going to start with a translation. So it says translate by, and this is going to say how much do we translate the x coordinates and how much do we translate the y coordinates. Let's see, if I want to map, if I want to get point W to correspond to this point right over here, which it seems like it should, I would have to go from x equals 2 to x equals -5. So my x would have to decrease by 7. So let me type that in, -7. And then, let's see, on the y side, and we saw that, so by just typing in -7 here, we've moved it to the left by 7. And now in the y axis, I need to move it down by, let's see, 1, 2, 3, 4. So my y coordinates, I need to move it down by 4. And let's see what happens. And it looks like I was able to successfully translate it by translating x by -7. Every point here, every point on this has been shifted to the left by 7 and has been shifted down by 4. And I was able to get onto this triangle. I was able to, through the translation, the image is now in kind of that target triangle that they asked me to map to translate to. We got it right.
Okay, you guys, so I lost track of what quiz question number we're on, but I believe it is question number 9. So if you will write question number 9 down for this next problem, it says, consider the quadrilateral as drawn below. Let's determine the translation that maps the source, FGHI, onto the image, FGHI, so the translation of FGHI. Okay, so to get from point F to the translated point F, it looks like we have to move to the right 1, 2, 3, 4, 5, 6. Okay, so to get to the translation of point F, we have to move 6 to the right. And then we have to move 1, 2, 3 down. Okay, so to translate this shape, we would have to take all 4 of the vertices of the shape and we would have to move those points to the right 1, 2, 3, 4, 5, 6, and down 1, 2, 3, and that's the way we would translate the blue shape onto the pink shape. So I want you guys to try this one on your own. This is question number 10 on your quiz. Determine the translation that maps triangle JKL onto the translation of that triangle JKL. Okay, so how are we going to map the blue triangle to the pink triangle? So just go ahead and pick one of the vertices, like if you pick K, and then figure out how you have to move from the blue triangle, the point K, to get to the pink triangle, point K. And I want you to go ahead and put that answer on your quiz. You guys are done. So once you have those 10 quiz questions done, please either text me a picture of them or upload them to the Dropbox. And we will continue our lesson on transformations on Monday. We're going to do transformations part 2. And we'll be talking about rotations, reflections, and dilations. So have a great day. And if you have any questions at all, please email me, text me, call me. I'm here to help you. If you need to practice some more of these, I would be happy to help you.